Hey everybody, welcome back for Psych lecture number 2. Today we're going to be starting chapter 2 here, looking at research methods. This is generally the second chapter in every Psych 101 class, and some think it's a boring unit, but it's very foundational and important for us in order to go forward in this class to see why psychology is a science, as we look further at famous experiments that have been done regarding this field and how they were done. So today we'll be looking predominantly at modules 4 and 5 as we look at the need for psychological science. And we're actually not going to talk about experiments today, but we are going to look at cognitive biases and specific scientific methods used, like case studies, naturalistic observations, and surveys, and kind of compare the three and see the differences, positives, and advantage, and also disadvantages of those types of research methods. This is generally a very important unit on your AP exam. It makes up about 8 to 10% of the exam, and you will usually see a research method question in the FRQ portion, and then you'll also see a few multiple choice questions on the AP exam as well regarding this chapter. So it's a very foundational unit. It's very important as we build our understanding of what psychology is and what it's founded on. So before we get into the research methods of how we find these answers, it's important for us to ask, well, why do we need those answers in the first place? Why do we need to use those research methods to begin with? Right? And the answer is because we don't want to fall we don't want to be entirely reliant on our common sense. Common sense is not a bad thing. We use it all the time. We use it every day in little decisions, right? If I'm walking in the woods and I see a bear, I'm just going to use my common sense and try to avoid that bear because it might eat me, right? But when it comes to more difficult and more complex questions that we have, maybe about human behavior, human development, human cognition, high hazard technology, and whether or not we should be building this massive factory and how we should build it, right, in order to protect the environment. Things like that, they need a lot more science-based inquiry on how to find answers for our questions, for our more complex questions, right? So with common sense, we don't use a scientific attitude. With psychology, we use a scientific attitude. We look at things through research methods. And that's why psychology is a science, because we are using common research methods like case studies, experiments, observational studies, correlations, to interpret data and come up with an answer to what we see and what we analyze. Now, we hear a lot of statements in life that are kind of repetitive. We hear them from our parents, we hear them from our teachers, we hear them from our friends, we hear them from our doctors, and we just kind of take them as common sense, common judgment, common knowledge. And one of those is listed here on the page. Breakfast is the most important meal of the day. All right, I heard that my whole life. Right, but when I inquire about that and start to look at, hey, why am I scheduling my entire morning over this meal? I mean, all my morning behavior, my money, my finances, my time is being spent right here on making breakfast because it's the most important meal of the day. Well, why is it the most important meal of the day? What's the research behind that? And what I've come to find is that, there's actually not a lot of research that shows that it is the most important meal of the day. There's a lot of research that disproves that. And that breakfast was actually a whole marketing scheme by like Kellogg's and these major breakfast companies to get people to buy their product. Where what we see when it comes to the human body, intermittent fasting is actually very good for the body. It's not only a spiritual thing. It's not only something that we look at in the Bible through prayer, but it's also something that is just really good for our bodies, as that is how God designed them to operate. And so if you look at the science behind fasting, you see there are a lot of benefits to it, and actually skipping this meal. That's using science to find an answer and changing my behavior around it, right? Now I want to look here at this second point down here, after the fact versus before the fact when it comes to these scientific-based answers in terms of predicting behaviors and predicting risk factors, right? Why do we need to look at life through before the fact rather than after the fact? Well, because if we're looking at things through after the fact, we're constantly living back here in 2020 vision of what we can already see versus, hey, let's try to predict what will happen. And by doing that, we need to ask ourselves more scientific-based questions and look at statistical analysis. If we don't do this, we fall susceptible to roadblocks to our critical thinking. And these roadblocks are known as cognitive biases. And we're all susceptible to these cognitive biases, right? When we base our decisions based off of our confidence or my experience, this is what happened. Well, we don't want to look at life completely through that lens when it comes to these bigger things. We need to look at things through a more clear-headed analysis of data. Like, for instance, the BP oil spill in 2010. Why did this happen? Well, BP employees wanted to make some shortcuts, right? They wanted to save some money. And they looked at the recency in history, and they didn't really see that anything had happened in the past 40 years in the Gulf. And so with their decision to go with a more budget-friendly approach here on the piping for this oil rig, they thought, hey, it's a win-win. What ended up happening is nobody really questioned them, and they were maybe overly confident in the judgment of these leaders for BP Industries, and millions of gallons of oil leaked into the Gulf, and 11 workers died on that rig as well, all because they weren't looking at it through a more statistical analysis of the risk factors, and they weren't looking at the warning signs. They were just kind of making the decision on their own confidence that things would be okay. And so how does hindsight bias relate to this? Well, from a bystander perspective, I could easily just point the finger and say I knew that was going to happen all along. Like all these oil refineries and these big oil companies, that whole sector is corrupt and greedy, and they don't care about the environment. And while that might be true in some sense, like I'm not entirely praising the oil industry, but as a bystander, I need to be careful of why I'm pointing the finger and pretending like, oh, I knew that was going to happen, and the government should have had more regulations on such and such, and I'm just so much smarter than everyone. I have all the answers, and I can see, with my 2020 vision of what's happening. Like anybody can see what happened with COVID, right? It broke out, and there are millions of infections in the world, and we didn't contain it very well, especially in the United States. It's easy for us as bystanders to point the finger and say, man, the government, you guys are terrible. You're terrible at containing this thing. You guys are so ignorant and stupid and etc. Right? So with this approach of your hindsight biases, it's really easy to stand there after the fact and make judgments about things. But it's really difficult to actually predict what's going to happen in the future. That's why we need scientific methods to avoid these massive roadblocks that cause a lot of damage. Okay, go ahead and answer this question regarding hindsight bias and overconfidence. I want you to use these terms to explain how their fans might use the following to explain the loss in the final game. So now that we understand why we need science-based questions, let's talk about what is a science-based question and what is a scientific attitude. Well, a scientific attitude uses research, okay? Uses the scientific method in which we apply a hypothesis through a systematic observation and or manipulation of variables. So observation, we're talking about descriptive methods. Manipulation of variables, we're talking about experimental methods. We're not going to talk about experiments today. But research in turn then helps either support or disprove a theory or previous studies that have been done about something. Okay? And when we look at the scientific method, it has three specific foundations. The first one is attitude. Right? We're talking about curiosity or passion or exploration of something that you're interested in. Right? Generally, that's what you do. Thank you. That's what you do your research on. Okay, something that you're interested in. Skepticism, doubting and questioning, right? This is when we inquire about things. Humility, the ability to accept being wrong about that which you maybe are very passionate about and want to prove. You also have to take the humility approach of, hey, I might actually be wrong about this. Otherwise, you'll fall susceptible to confirmation bias. Okay, so within the scientific method, we have these three categories of research that we use. The first is descriptive. Descriptive, we're looking at what we're going to be talking about today: surveys, case studies, observations. The next is correlational methods. Okay, when you're looking more so at patterns and looking at patterns and variables and maybe previous research that was done. Obviously within correlational studies, you cannot say that it is the cause of something. You can just say, hey, I see a relationship between these two variables. And then you have the experimental method, which is where you actually can find causation because you're manipulating the variables and you're in control of the environment. Now, while the scientific attitude is great, any type of research, you can't just go out and make a blanket statement and say, this is a fact, right? It's 100% fact, okay? Because there's research here that I published on this article here that was done in 2012. They published it in 2015, and it was the reproducibility project at the University of Virginia. And what they did was they tried to replicate 100 of these published psychological studies that had been put in 3 very well-known and recognized psychological journals. So those were Psychological Science, the Journal of Personality and Social Psychology, and the Journal of Experimental Psychology, Learning, and Memory. And what they found is that only 36% of those studies were actually able to be replicated and repeated. So this kind of just goes to show that we do need to question the reliability of these studies that are out there. So science is great, but it's not absolute. The point I'm trying to make. So when we look at the scientific attitude, we have to look at it through a sense of observation. So theory versus hypotheses. What is a theory, right? A theory comes generally first before a hypothesis. Before we can start our research, we need a theory. And when we have this theory, this helps us kind of make a decision about where we want to go with our research. We're not just taking a bunch of random facts and starting from all these random facts about things. We look at prior research and theories that are well documented, like, say, theory of evolution. Okay, if you were trying to disprove the theory of evolution through one hypothesis, you would be highly unsuccessful, right? The theory of evolution is founded on many hypotheses that support it, right? That's why it's called a theory. A theory is a well-supported foundation, okay, derived from many hypotheses. It's not a fact, okay, but it is a theory that is well established and well supported by many different studies. So a hypothesis is a tentative statement, right, about a relationship between 2 or more variables, or events, could be behaviors, could be characteristics, and we take those variables and we put them in a controlled setting, right, where we then observe them and we observe what happens and we try to find out the causality of those variables. So a hypothesis, using maybe something related to human behavior, we might say prisons in which inmates have the responsibility to train service dogs experience lower levels of violence than prisoners without such programs. So here I'm studying, I have a topic, it looks like, right? The topic is related to violence in prisoners. And so I'm trying to find the cause for this. So I look at it and I say, service dogs, training service dogs, having a companion there to train is going to help lower their levels of violence versus those that don't, right? So my independent variable is going to be what I manipulate, right? Giving the service dogs. And then my dependent variable is going to be the result of that, okay? Their violence levels. We won't get into all that right now, but this is an example of an experimental hypothesis that I would be using to manipulate the variables. So in order to come up with a hypothesis, I need to select a topic, right? I need to define a problem. I then need to review literature and look at other theories from previous studies, and then really after I do that, then I can come up with the hypotheses for my study. And then I go even further. I have to think of a research method that I'm going to use, right? So there's a lot of steps in research, and we need to make sure we do every single one correctly. But when it comes to coming up with a hypothesis, you don't just take random facts and then, well, let's just study this, right? You do a lot of research before you even have a hypothesis generally. Now, once I've formulated my hypothesis, I need to operationally define the variables in my hypothesis. So this is a very, very important term. Please make sure you remember this. I promise it will be on your exam in May, and it will also be on your unit test coming up. Operational definitions are precise descriptions that define the exact method of the variable that we're measuring, right? If I'm doing a study and my study is involved about the SAT vocabulary words, I want to measure the relationship between rehearsal and recall. So I'm studying about human memory. I've got to define those variables. Like, when I'm looking at relationship, what do I mean by relationship? And what do I mean by rehearsal? And what do I mean by recall? Right? If I'm trying to replicate someone's study and I don't know what they mean by recall, and recall could be the percentage of words that the subject's able to remember and recall and rehearse. If I don't have that specific definition, if I don't have what does difficult mean, well, answers to level 5 SAT sentence completions would be considered difficult, okay, rather than level 3. So the level 5s I would consider as difficult. What does rehearsal look like? How many times a day are these people going to be recalling these words from the list? All of those things have to be taken into consideration when doing an experiment. You've got to define your variables, otherwise your research is worthless. So let's look at an example here. I want you to practice operationally defining these words: smile, intelligence, and anxiety. Okay, after you record it, I'll give you the answers. Hopefully you had some good practice there with the operational definitions. That may show up on your AP exam in May. They may ask you to operationally define your variables, or the variables that they provide you with, right? Or if you take AP research, then you'll have to do that in that class. So now that we know what a hypothesis is, and now that we know the purpose of them, they're either to prove or disprove theories, we need a research method. That's the next step in our research, okay? And there are 3 different types of research methods: descriptive methods, correlational methods, or experimental methods. And we're going to focus more so on the descriptive methods today, looking at case studies, naturalistic observations, and surveys, whereas correlational methods are going to look at statistics and data and look at correlational coefficients, where you're trying to basically state whether or not there's a relationship between two different variables, okay? Depression and maybe gender, or autism and gender. Okay, that's a correlational method. You're not finding causality. And then with experiments, you're actually finding causality because you are manipulating those variables. So these are the methods that we use to refine theories. The first method we're going to look at is the survey method. Okay, and the survey method, this research method relies on surveys, questionnaires, and interviews. And the advantages of it is that it's quick, right? It's very efficient. Doesn't take a lot of time. It's inexpensive. Anybody can give a survey. You could give a survey, right? You don't have to go raise a lot of money. You don't have to pay people to be in the experiment. That's where experiments can get very pricey. You don't really have to buy a lot of materials for it. You don't have to rent any property for it to perform it. So they're very inexpensive, and you can also address multiple variables. You can measure various different things instead of just maybe 2 things. Like in an experiment, it's a little more difficult. It takes a lot more time to measure various variables. So those are some of the advantages of it. Some of the downsides to the survey method is that you have things like wording effects. Okay, I can skew the data just by changing the words. Like if I use the word bumped versus smashed in a question, like how fast was the car going when it bumped into the car in front of it, versus how fast was the car going when it smashed into the car in front of it, right? It's gonna get people to respond very differently. And if I'm on the insurance side and surveying various different people who witnessed the event, and I'm trying to prove that it was the other guy's fault, right, by just affecting the survey and the question, I can skew the data. You also have the fact that it provides very shallow information. So in this case, you can't really follow up with the surveys, right? It's a very limited interpretation of the data that you're receiving. So surveys are shallow. Not necessarily that they're always bad. I'm not saying they're bad, but they're not as qualitative. Okay. They're more on the quantitative side than they are on the qualitative side. There's no causality. Of course, with any descriptive method, you're never going to have causality because you're not manipulating the variables. You're not in control of the environment. So you'll never truly know the cause. You can only know maybe correlations of the relationships. And lastly, another thing is could have double-barred questions. I didn't write that on there, but it could have double-barred questions, which are asking a question that has two meanings in it, right? And for instance, I could say, should cars be, I could say, do you agree with this statement or do you disagree with this statement? Cars should be faster and safer, right? I'm measuring two things within that one statement. It's a double-barred question. I should just say, should cars be safer? Right? Should our cars be faster? Okay, I can't put both of them in the same question. Otherwise, it's a double-barred question, and you run into issues. So things that it does need to include now. When it comes to a survey, you guys will probably be doing surveys throughout the year. If you take any sort of research class, and we'll actually probably do some surveys in here even sometime this semester. But you need to have a valid population. So the population is the total large group being studied, right? So that could be ICS high school students. That could be Hong Kong. That could be new territories. That could be the area. That could be Psych, right? It could be Wichita, Kansas, where I'm from. So I need to have a large population. And then after I have that, I need to make sure it's a representative sample. So I need to look at what's called demographics, right? The demographics need to be there. And in that case, I need to take into account gender. I need to take into account ethnicity. I need to take into account age, right? Maybe religion. All of these things into play when I'm trying to have an equal demographic in my sample. And then it also needs to be a random sample. Okay, a random sample is a representative sample that gives everyone a chance in the larger population a chance of being in that study, right? So I've got to have some sort of way of randomly selecting people. So those are very important when developing a survey. All right, the second method we're going to talk about here is observational studies or naturalistic observation. So this is when we're recording behavior in real life settings. So the advantages is that it's an authentic environment, right? And very revealing in terms of that person's character, that person's behavior. It's the very opposite of an experiment, right? Where an experiment is completely controlled. Naturalistic observations are completely out of your control. They're completely authentic, right? You avoid the Hawthorne effect, which causes demanding characteristics. Okay, the Hawthorne effect is when people act differently because they know they're being watched by the researcher. So this changes their authentic behavior from unauthentic behavior. So that's the problem with experiments. But with this, you actually get authentic behavior. Disadvantages: you can't necessarily generalize it, and you don't know what variables are really affecting that individual's behavior, right? If you're studying children's attention and in school, right, and you're naturally observing that, there could be various things. There could be various variables that you have no idea, right, that are causing that child to lose his attention or her attention in the classroom. So, because you're not in control of the variables. So that is a disadvantage. And then, of course, there's no causality, right? So they're great for looking at authentic behaviors. But the problem with them is, well, you're not in control of the variables. So you don't always know what it is that is causing the behavior. And then I had these videos that I wanted to show you guys. I'll just post the links to them. And they were just, one of them was a silly video from Parks and Rec. And this was an observational study that I wanted to show you guys. So lastly, case studies. When we look at case studies, it is an in-depth study of one individual or a very small group with hopes of determining universal principles of behavior. The problem with case studies is they can't really be generalized to the vast public because they're focusing on one individual, right? So what happens in one person may not be the case for everyone, right? What happens in a female may not be the case for what happens in males. What happens for all humans, right? What happens in one 11-year-old may not be applicable to all 11-year-olds. So that's a huge downside to case studies, is they can't be generalized to the public. But we can learn from them. And one case in particular is Phineas Gage. We did learn a lot from Phineas Gage. Phineas Gage's case study on the prefrontal cortex and its associations with our personality. And there's a lot of evidence because of this case study that has now kind of come out that shows that this region of the brain is very much associated with our personality. Phineas Gage was a railroad worker, and he one day had a metal rod that shot through his head, right through his cheek and through his skull cleanly, and he lived to tell about it. He lived for like 11 or 12 years after the event happened. And what they saw was these huge changes in his personality. He went from being a very kind and caring person to being a very profane, vulgar, and angry individual. And so later research took Phineas Gage's extreme event, right, extreme scenario, and started looking into this region of the brain. And it caused people to ask questions. And so case studies are great for asking questions, but we can't necessarily take them and generalize, take them as applying them to the general public. So these are the common descriptive methods used in research. And I just want you to go ahead and try to answer this question. Okay, and the answer is A, choosing a representative sample. And then I have one more question for you guys on here. A little bit of a FRQ practice for you. Okay. Dr. Shima is interested in studying the prevalence of cheating on exams at her local high school. Describe one advantage of using each of the following research methods to study this topic. Okay, so go ahead and record your response, and then I will post the answers for you afterwards. All right, that's it, guys. Take care. See you later.